So I'm Sam Buck, and I'm going to be talking to you today about electric micromobility, aka electric scooters. I'm Sam Buck. Everyone that knows me, first thing that comes to mind is I'm a ballerina and I love infectious diseases. I have my degree in epidemiology and molecular microbiology, and now I'm a data scientist. But above all of that, a scooter enthusiast, definitely with the scooter pilot we had in Denver. My project was actually on the one done in Chicago. They released their data for their 4-month pilot they did in 2019 that had about 650,000 trips. And my goal is, we all know about shared rides like Uber and Lyft. So now shared micromobility is becoming a huge part of the transportation sector. It's a sustainable and equitable way for cities to help people get around if transit's not there, if they can't have cars, drive them to work. So how can these e-scooter companies increase their profit and do well just like their car counterparts? So how I'm going to do that was to apply an inferential model to the data to see if certain factors relate to a higher profit, which in the scooter world means more rides, just that's how they make their profit. And do any of these factors relate to each other? Now, because I didn't have a target variable, I did unsupervised machine learning and was doing clustering. I specifically chose k-means clustering, which really is just to discover underlying patterns in the data and then group those data points together if they have something similar. So as you can see on this screen, there's some data. They got put into 3 clusters. So it finds a center of that cluster, and then it determines how close each of those points is to the center, and then it assigns a cluster. So for my data, I decided to pare it down to 6 features for the model, and I'm going to show you some of those. The first one was scooter trip daily frequency. So what day of the week the scooter trip happened. As you can see, it's pretty average around the board. I mean, a little bit higher on Friday, Saturday, not really much to see. The time of day for the scooter ride was actually surprising because I thought there'd be some in the morning and in the afternoon, but it's really a lot around the end of the workday, maybe going out to happy hour with coworkers, going to a show, going to dinner, etc. And then I also was looking at the ride origins and ride destinations. As you can see from this, you can't really see a difference between that. So I didn't want to add another feature to my model. So I got rid of destinations and just did the ride origins. And then the other 2 were actually the ride length in miles and the ride distance or length in minutes. So how long the ride the person had the scooter checked out for. As you can see on this result, the table shows those other 4 that are more of the continuous variables. And then the map is showing the 5 clusters, their ride origin coordinates. They're kind of all clustered together. And you can see that from the heat map. This happens to be around a park in Chicago called Humboldt Park. This is a place that has a lot of like restaurants nearby, art galleries, a lot of things to do in the park. And this study happened during the summer. And then as you can see from the table, other things that happened in the clusters was Thursdays around 3 to 4 p.m. But the thing that was surprising to me was these 2 clusters that had the trip lengths of over an hour and a half to 3-hour trips, which you're only going 4 miles and it shouldn't take you that long. So what I would recommend first is to do further analysis on the data set around those clusters. Is it because there's not enough scooters available? As a person that's used a scooter a lot, maybe you're taking it to somewhere, you're going to be there for an hour, you don't want to lose your ride home, so you keep it unlocked. So maybe they're losing rides because there's not enough for people, so they need to deploy more scooters. Another thing I did was I had taken out any rides that were under 2 minutes because it could be someone that's just trying to see what's a scooter like, but that might also be when they need to look at, do people unlock it, realize there's not enough battery left, and so they're not going to use it. So they're losing profit there again. So they need to check battery life. And then they should focus on weekday afternoon deployment. So from this model, Thursday afternoons between 3 and 4, but as you can see, it was kind of consistent around that time across the board. So they should focus on redeploying scooters in the afternoon to the high areas, maybe around that park or around certain business districts that have a lot of young workers. And then again, this pilot was only over the summer, which I think is why there was a lot around that park. So if they could extend the pilot over the whole year, so you can see with the seasonality that happens in Chicago, what you're going to need to do. Future work, definitely work with the continuous and categorical data. Right now, I just did it all as continuous. So that's probably why Thursday came up, because it was the number 3. And so that was just the mean of the 7 days. And then really look at a difference between where those scooter trips are happening and the clusters are with pedestrian and bike infrastructure. People may not be riding them because they don't feel safe in these areas. So how to work with that in the city with transit stops and getting more infrastructure in. And that's all. And thanks. Any questions?